So this topic is writing and evaluating a function modeling continuous exponential growth or decay, giving doubling time or half-life. The problem says a specific radioactive substance follows a continuous exponential decay model. It has a half-life of 7 days. At the start of the experiment, 89.3 grams is present. So we have this graph of a substance which says that it's radioactive, and we know that its radioactiveness decreases as the time goes by. So we can see we have an initial value here of 89.3, which is going to be decreasing as the time goes by. So this is a function that looks something like this. And we are told that we want to find what is this function exactly. We want to find the values that makes this function match the graph. So we have y equals something times e t to something. So we want to find these two values that are unknown, these two constants. Let us call them a, oh, more space here. Let us call them a and b. A and b are the constants that we want to find in the first part of this problem. How are we going to find them? So let us look at the constraints that we are given in the problem. We have a few constraints here. First, we are told that when the time is 0, here you can read at the start of the experiment 89.3 is present. That means that when t time is 0, y is 89.3. That is a first constraint that we can get from the description. What else can we find here? It tells us that it has a half-life of 7 days. 7 days. Alright, that is nothing but telling us that when the time is 7, the mass should be the initial mass over 2. We know that this is over 2 because in the description of the problem we are told it has a half-life, meaning that but 7 here, this point here, will be half of the initial volume. That is these are the two constraints that we need to solve this problem. Now that we have the function and the two constraints, let us evaluate in the original function. In this one, let us evaluate first this constraint and then this one. Okay? So let us replace, instead of y, I will write 89.3 equals a, which is the number that I don't know, times e to the b, which is another number that I want to find, times t. T is the independent variable. Now, instead of t, I will write the value when 89.3 is present, which is 0. And I know it from here. When t is 0, y equals 89.3. The rest here is reduce the expression by doing some math. And here I know 89.3 equals a times e to the 0, because this times this is 0. And I know that any number to the 0 is 1. So from these first two constraints, I can conclude that a equals 89.3. That is the first value that I want to find. And now that I have it, now that I have found it, here I will write it here. It is no longer an unknown value, so I will just place it there. So now I know that my function looks a little bit like this. Y equals 89.3 times e to the bt. We also have to find b. So that we can find b, now I'm going to use these two constraints, the ones that I haven't used. So I will replace them into my new function here. Instead of writing y, I will write 89.3 here. Make some more space. 89.3 over 2, which is the value here that I have, equals 89.3 times e to the bt. B is a number we don't know, so I will just write it b, and t is 7. Here I have the 7. Now I just have to solve this exponential equation. I will take this number to the right side because I need my b to be alone, so I will have this as 89.3 over 2 times 89.3 equals e to the 7b. Now, I know that this number and this number can be divided into one number. So I'm going to have 1/2 equals e to the 7b. Now from this point, so that I can solve this exponential equation, I will apply a natural logarithm on both sides. Natural logarithm of both sides. So I will have the natural logarithm of 1/2 equals the natural logarithm of e to the 7b. And I applied natural logarithm because I know that there is this power rule of logarithms, in case you forgot, that whenever I have, for example, the natural logarithm of 5 to the 3, I can rewrite that as 3 times logarithm of 5. This is the power rule. So I want to apply that here, so that's why I added a natural logarithm of both sides of the equation. If I apply that, I can rewrite this as 7b times natural logarithm of e equals natural logarithm of 1 over 2. And here, I know that natural logarithm of e, this part here, is 1. So I can write just 1 here. And that lets me with natural logarithm of 0.5, which is the same as 1/2, it's the same number, equals 7b. Now all I have to do here is move this 7 to the left side. So it's going to be natural logarithm of 0.5 over 7, and that is b. That is value b that I was missing. Now that I have found the value of b, and now that I have found the value of a, I will replace that into my original function. Like I have it here, actually. The original one. I will write that here again. So it is y equals a e b t. And I know a is 89.3. E and b is the value that I found here. Natural logarithm of 0.5 over 7. Natural logarithm of 0.5 over 7 t. And this is the answer for the first part of the exercise. Let's click here. There you see it. Now, for the second part, it asks me how much will be present in 6 days. So what I have to do here is take this function and evaluate it. I have to evaluate it in 6. Pretty easy. 89.3 times e to a natural logarithm of 0.5 over 7. And instead of writing t, I will write 6 because I am evaluating the function. And I can use Alex's calculator here for this one. That is 89.3 times the here, natural logarithm. The natural logarithm, no, oh, 89.3 times e to the natural logarithm of 0.5, this whole number, over 7, this times 6, like this. And the answer is there, 49.297, and I have to round the answer, so that's what I see here, 49.3. Okay. In this particular exercise, we have to take the half-life. So in the constraints that I said here, I divided the value by 2, but there are other problems where there is no half-life, but like this one is a continuous exponential growth. In that case, it mentions that it is doubling. So instead of dividing by 2, I should multiply it by 2. And that's the only difference with those problems, but they are solved the same way.